Briano, sir, you may begin.
Thank you, Carissa.
Briano, sir, you may begin.
Thank you, Carissa. Good morning or good afternoon, everyone, depending on where you're calling in from. My name is Gene Amparano with the Federal Highway Administration. I'm on the Safety and Design team. This is our 11th of a series of 12 webinars. Today's topic will be on HSM applications to roadway departure crashes. But before we get started, there are a couple items I'd like to go over. First of all, you'll notice in the upper right-hand corner, we have a poll question. We're trying to keep track of the number of participants that are participating in the webinars, so if you would please select the appropriate box with respect to the number of persons that are participating from your location. We'd greatly appreciate it. You should have a full screen toggle capability on the presentations. When we get to the presentation room, it will allow you to toggle to a full screen if you so desire. As Carissa noted in her introduction, we will be taking questions at the end of the presentation. So if you have urgent questions, you can put those in the chat pod and we'll address them as we can. And if for some reason we can't address them during the presentation, we'll come back and review those questions in the chat pod and address them at that time. Also, you will notice that underneath the poll question, there is a file share pod. There you can download copies of all the presentations from today's webinar and from our previous webinars. You also find copies of HSM spreadsheets that can be used to facilitate calculations using the HSM crash prediction methodology. Today's webinar, again, like I said, is on roadway departure crashes. Our instructors or presenters will be Dick Alvin and Frank Julian from the Federal Highway Administration Resource Center, Safety and Design team. First, they'll be discussing definitions of roadway departure crashes, and then we'll be going into the introduction to the Highway Safety Manual. And if you've participated in some of the previous webinars, some of this information may be a repeat for you. But for those who were not able to attend the previous webinars, we feel that it's still worthwhile to present this information again just for their benefit. And then they'll be discussing crash modification factors for roadway departure crashes, and we'll be also looking at some other resources. We do have a closed caption pod down at the lower right-hand corner. There is a setting, if you click the CC button, that you can go take you to a font menu that you can change the size of the font if you so desire. And right above the caption pod is our file share pod that has links to all of our recorded sessions from our previous webinars. So if you were not able to attend a previous webinar, you can select the appropriate link and they're listed in dates, and you can go back and view those recordings at a time that's convenient for you. Okay, with that, I'm going to go to the presentation room. And I will turn it over to Mr. Frank Julian. Frank?
Thank you, Gene. We went to the wrap-up. What happened? Load it back up here and see if we can't get back in presentation mode. As Gene mentioned, we're going to be talking about roadway departure crashes today and how it relates to the Highway Safety Manual. I'll start out with the first session and give you some of the things that we'll be talking about. And we'll define roadway departure crashes to start with, because that's going to vary some with what your state does, possibly. We'll describe what is in the Highway Safety Manual as it relates to roadway departure, and discuss how roadway departure crashes are evaluated in the Highway Safety Manual. What are roadway departure crashes? Roadway departure crashes, by the federal highway definition, is a non-intersection crash in which a vehicle crosses an edge line, a center line, or otherwise leaves the traveled way. Now, this may vary slightly with what you have in your state DOT. You may have a different definition for how you actually account for these, so be aware of that. What you see on the right is the numbers, the fatal crashes from the 2008 national fatal crashes. So you can look at, there's kind of a breakdown, but it looks about 53% of the fatal crashes in 2008 were roadway departure crashes. You can see the breakdown there: run off the road right, 24%; run off the road left, 10%; crossover, 17%; of course, unknown roadway departures, 2%. This tells you this is a major issue. You can see why we're addressing this as a separate session. Here's a map of the United States. It basically shows you, so you can go in and look at the percentage of roadway departure fatal crashes in your state. For example, California, 48% of their fatal crashes are roadway departure crashes. You can see every state has a breakdown. Now, what is the Highway Safety Manual? Well, in essence, the Highway Safety Manual has been put together so we can, based on research, and we're going to quantify safety. This is the big advantage of Highway Safety Manual. It's a synthesis of validated highway research. And you can see some of the research is rather recent, but also there's some that has been around for a number of years that has been vetted, and it was a robust study to start with. So you can find that some of the best information you can find on highway safety countermeasures and effectiveness is going to be in the Highway Safety Manual. It has a lot of analytical tools for predicting the impact on roadway safety. It's a rather large document with more than 1,000 pages, very comprehensive. It's a great opportunity to advance safety in the United States. It's been underway for a number of years. Some of the first work done back in 1999 started the ball rolling at TRB. And what we've had is a lot of research that was looked at, was what was existing and evaluated, but also the defined gaps that needed to be researched. And you can see there's been a lot of research done over the years to get to the point where we can actually put out the first edition in 2010. And that's what if you have a book, as many states have started receiving those recently, you'll see that that's a rather large document and it's based on a lot of really good research. Yet you'll find that there's a need for future editions because there are some gaps still lacking. We see this kind of like the Highway Capacity Manual. It started out many years ago, and it has grown over the years with more and more research. But the methodology is the same for assessing and assuring the adequacy of capacity as it would be for safety. We're going to move in that same process. And the Highway Safety Manual will allow the transportation professionals to understand and quantify highway safety performance for informed and balanced decision making. That's critical to where we are today with safety and trying to balance other needs. That leads into our slide where you can see that we actually have why do we need the Highway Safety Manual and why is it needed. And that is basically we have requirements for all these other areas like environmental impacts, right-of-way cost, and capacity. So we're trying to balance those needs. Well, you need facts. You need to be able to quantify to be able to do that. Okay, uses of the Highway Safety Manual. The Highway Safety Manual can be used to identify sites with the most potential for reducing crash frequency, identify contributing factors to crashes, calculate the safety effects of various design alternatives, estimate potential crash frequency on highways, estimate potential effects on crash frequency of planning, design, operations, and policy decisions, assist in review and documentation of design exceptions, variances, and waivers. And today we're going to be talking about, well, I'm going to lead in with the four parts that primarily make up the Highway Safety Manual. Part A, Introduction to Human Factors and Fundamentals. Part B, Roadway Safety Management Process. Part C, Predictive Methods, which we're going to talk about primarily today. And we will also get into Part D, Accident Modification Factors. Now this says Accident Modification Factors. In the final version of this, it says Crash Modification Factors. That was a big discussion that's been going on for the last couple of years. But when you get your book, it'll say Crash Modification Factors. And this is something that, again, points out to the discussion that we've had a number of people involved in this, and there's a widespread input into this book. And there's a different meaning for accident versus crash. And of course, this is, again, was agreed upon to say crash. In Part C, predictive methods, where we're going to focus a lot today, Chapter 10 primarily deals with two-lane rural roads, Chapter 11 with urban suburban arterial highways, Chapter 12 with rural multi-lane highways. The commonality to all these chapters are you'll see down as safety performance functions, crash modification factors, and of course then there's also a discussion in the appendix Chapter C for calibration for local conditions. These are this crash modification factors and safety performance functions. You'll notice under safety performance, SPF, those are the letters that are underlined, and then CMF. Those are terms you'll see us throw around a lot of times. Make sure you understand when we say SPF, we're talking about safety performance functions. And these are primarily the backbone of the whole process. We'll get into that in just a second. Chapter 10, 11, and 12, safety performance functions, models for roadway segments and intersections, crash modification factors. Today we're going to be speaking specifically about this roadway segments. So you can look at these and say that they're used to determine crash frequency for a set of base geometric and traffic control conditions. There's crashes per year. That's the way the results are. We'll get into that detail a little bit more. And then under crash modification factors, they adjust the prediction for the base condition to the actual or proposed condition. Now, when we say that, and Dick's going to get into the crash modification factors later on in this session, the base unit, I think will become more apparent when we get into the next few slides. Under Part D, Chapter 13 deals with roadway segments. Again, that's where we're going to focus our discussion in Part D. But you can see that we also have sections that have been covered in other webinars under Chapter 14, intersections, Chapter 15, interchanges, and 16, special facilities and geometric situations, and roadway networks, Chapter 17. Use of the Highway Safety Manual. How can a crash prediction be used? This is where I think we get into where I think most practitioners can really start to embrace the Highway Safety Manual. Certainly on the program level, you can look at prioritizing segments or locations for selections of projects, where I think it has a tremendous benefit in the project level to assess the relative needs for a project. Look at the beginning level. This is not just a document for safety engineers. This is a document for planners and people preparing environmental documents and things of this nature. But you can communicate the relative needs to the public and prioritize work to keep project within budget. That's just reality. Sometimes you have to weigh out what you're going to include. And support documentation for design exceptions. So you can actually quantify what you're doing. You can actually go back in and look at the effects of a design exception. But I think that number 2 bullet there, communicate the relative needs to the public, is very, very strong. In some of the sessions we've been hosting that are live sessions, the feedback has been coming out very strongly. Boy, I wish we'd had this when we had such and such project, because we could have really used this to quantify what alternates we were picking. So basically, if you go in and look at alternates, you can really see a strong benefit to being able to compare alternates and why, justify to the public why you selected that option. And the last bullet down there is tort defense if used properly. And what it's saying is this tool can help quantify the relative safety of a facility and demonstrate that an agency is addressing safety needs appropriately, particularly if that agency has a priority program that helps them understand selection process. Now let's talk about the roadway segment prediction model. Now you'll notice that the N has got predicted -RS, meaning predicted, that's the total prediction for the roadway segment. And you start off with the N with the SPF-RS, and that's the safety performance function for roadway segments. And that is again, we'll talk about that equation. That breaks down in a separate equation. And then you'll notice that it's multiplied times the CMF-1R, and it says on through CMF-12R. That's the number of modification factors that we have in roadway segments. Now you'll also notice at the end of that equation there's a CR. That's the calibration factor. And again, that's what's discussed in Appendix C, the calibration factor. This is the overall, and that's crashes per year you'll come up with, that N predicted-RS is the overall crashes per year. Now, the safety performance function, which again, as I said earlier, is one of the backbones to this whole approach, is predicting highway segment crashes for base conditions for the two-lane rural model. And this is the two-lane rural model we're showing. And that's the safety performance function, or base condition. And as you can see, there's really two variables, ADT and L, which is the length of roadway segment. And of course, that's in miles. And so you can see that we have a pretty basic condition. We're making some assumptions here that we'll talk about in a minute. But the ADT is vehicles per day, of course, for a specified year. Now, here's our base conditions. Now, this is important to realize which conditions are, what are the assumptions in that base model. We're looking at a lane width of 12 feet and a shoulder width of 6 feet, shoulder type being paved, and a roadside hazard rating of 3. And Dick's going to cover some of these, particularly that roadside hazard rating, talk about that a little bit in the CMS. And then driveway density, you're assuming 5 driveways per mile. And the grade is level. Horizontal curvature, none. Vertical curvature, none. Centerline rumble strips, none. Two-way left turn lane, climbing or passing lane, none. Lighting, none. And automated enforcement, none. How do we come up with these values? Well, it's really a statistical determination. It was based on the mean values for these variables were in the database, and what this means is that the regression model estimates have the least standard error near the mean. So therefore, these are the values. It's not necessarily the safest. It's just what came out of the data set. And it was and you can look at that as a statistical determination, a statistical reason for that dimension. So what we're going to do, once we understand that, we move into safety performance function for the crash prediction. And here's an example. We have a 2-lane secondary state highway connecting a U.S. marked route to a primary state marked route in a rural county of 25,000 population, where the ADT is 3,500 vehicles per day, and the length is 26,485 feet, but we need it in miles, so it's 5.02 miles. So we can just plug that into our equation, where ADT is 3,500 and length is 5.02. Plug it into the equation, chug it out. You can see how this is just a matter of multiplication. We come up with 4.69 crashes per year. This is the base condition. Now I'll turn it over to Dick to talk about how we would adjust that base condition.
Okay, again, my name is Dick Albin, and what I'm going to talk about first is some of the risk factors that are involved with roadway departure. When we think about roadway departure, there's 3 main risk factors that we consider. First, what is the risk or what are the chances of a vehicle leaving the roadway? Then, if a vehicle does leave the roadway, what are the chances that it's going to crash into something? And finally, if it does crash into something, what is the potential for that being a high severity crash? And when we think about some of the crash modification factors and some of the countermeasures we have available for us, it's important to really kind of understand what are we trying to achieve. If we're trying to achieve keeping the vehicles on the roadway, that might be a different set of countermeasures and on down. So how can predictive equations be used for evaluating roadway departure crashes? And again, it gets into the crash modification factors. The crash modification factors are used to quantify the expected change in a site if we're going to implement a treatment or countermeasure or action. They're also used to adjust the SPF if you have a highway that doesn't have your base conditions. It allows you to adjust for those to get a more accurate measure of the number of crashes that you can expect. The crash modification factors are expressed in a value based on 1. With a CMF of 1, it means that it meets the base condition or that treatment isn't expected to have any effect on crash frequency. If the CMF is less than 1, the treatment reduces the crash frequency. If the CMF is greater than 1, the treatment increases the crash frequency. Said another way, I know a lot of people might use the term crash reduction factor, and they're related, but they're different. For example, if you had a CMF of 0.8, that would be a 20% reduction, versus a CMF of 1.1 would be about a 10% increase in the number of crashes. So it's important to understand those. And when you see an M in the middle of your acronym, that means it's a modification factor, and it should be based on 1. So if we go back to our risk factors, the first one being evaluating the potential for a vehicle leaving the roadway. The Highway Safety Manual has several CMFs that can help us assess the effect of different elements. I will say that it doesn't include everything. The Highway Safety Manual pulled together the best research that was available at the time that it was published. There's ongoing research that will change in the future, and we'll gather more information. But this is what's available to us right now. For rural roads, all rural roads, we can look at lane width, shoulder width, horizontal curvature are some of the factors that affect vehicles leaving the roadway. When we look at two-lane rural roads, we also have a countermeasure of center lane rumble strips that there is a CMF available for, and I'll be going over each of these. First off, for lane width, and this is for a two-lane rural road, the base condition is a 12-foot lane. And the crash modification factor shows that for 11-foot lanes, you might have a CMF of 1.05, for 10-foot lanes at 1.3, for 9-foot lanes, a CMF of 1.5. And those are all for ADTs that are greater than 2,000. When you get into lower ADTs, lower than 400, those were developed under a separate study that looked at lower volume roadways, and you have a lesser effect on the crash modification factors for lower volume roadways. And then the area between 400 and 2,000 was connected as a result of expert opinions and evaluation that thought that was an appropriate relationship. So these crash modification factors for lane width, it's important also to understand where they apply. And there's a note on this table that I've just circled, and I'll blow that up for you, that shows that the factor applies to single vehicle run off the road and multi-vehicle head-on and opposite direction side swipe and same direction side swipe crashes. So they don't apply to all crashes on your roadway. When Frank was going over the SPF earlier, that was looking at a total number of crashes for the example that he gave. But since this CMF only applies to a certain number of crashes, we need to consider that. And there is an adjustment that can be made to relate it to the number of crashes that you'd expect. And so you can adjust it looking at the runoff road, the head-on, and the side swipes. This table 10.4 that is up on the screen right now is a default distribution of different crash types that is found that's contained in the Highway Safety Manual. For runoff road crashes, it shows that about 52.1% of crashes on two-lane rural roads are runoff road. About 1.6% are head-on crashes, and about 3.7% are sideswipe crashes. When you total all those up, that comes up to about 57.4%. So that is your proportion of crashes that are relative to lane and shoulder width. And so to come up with an adjusted crash modification factor, you need to incorporate that into the equation as shown. And I'm going to go over an example of that next. So the example is we have a ADT of 3,500, a 10-foot wide lane. If you go to the table or the figure, you came up with a CMF of 1.3 for a 10-foot wide lane, since it's over 2,000 ADT. But we know that that only applies to 57.4% of the crashes. So we use this equation. We put in 1.3, subtract 1, multiply by 57.574, and then we add the 1 back. And that results in an adjusted crash modification factor of 1.172, which basically means about 17% more crashes overall of total crashes. There's a very similar table or figure for shoulder width. The same studies were used to develop this CMF. For a 2-lane rural road, the base condition is 6-foot wide shoulders. So you can see it's 6 foot wide, it's a straight line with a CMF of 1. However, you also have a condition where you might have wider shoulders, and so you have a CMF of 0.87. And as you get with narrower shoulders of 4-foot shoulders of 1.15, or 2-foot shoulders at 1.3, and no shoulders at 1.5. Again, those are still based on the 57.4% of crashes, though, so you have to go back and factor that in. In addition to shoulder width, you also have a CMF for shoulder type. So the base condition for shoulder type is a paved shoulder. If you don't have paved shoulders, if you have gravel or composite or turf shoulders, you use this CMF to adjust for that. And you can see the biggest difference is when you have a turf shoulder. When you get into wider turf shoulders, you have a 1.11 CMF for turf shoulders as opposed to a paved shoulder at 1. So here's just an example, again, of the calculation of the CMF for shoulder width and type. Again, we have the same conditions of 3,500 ADT. In this case, we're going to say that we only have a 2-foot wide aggregate shoulder. So if we go to figure 10.8, we get a CMF of 1.3, and we use table 10.10 and get a CMF of 1.01 for the aggregate shoulders. Again, we apply that to 57.4% of the crashes, and we multiply that through 1.3 times 1.01 minus 1 times 57.4%, and then we add the 1 back. And so the total for shoulder width and type gives us a combined adjusted CMF of 1.18. Again, that means about 18% more crashes because you have reduced shoulders and they aren't paved. So now we'll look at the combined effect if we're looking at lane and shoulder width together. In this case, we're going to say that we have a 1,500 ADT. And again, if you recall back to the lane and shoulder widths, it's between 400 and 2,000, so it's on the sloped line of those figures. So we don't use the numbers that are we're at flat lines. We have to interpolate between those. In this case, we have no shoulder. As you can see in the picture, it slopes off right into the bottom of the ditch. For our lane width, having a 10-foot wide shoulder, 10-foot wide lane, we go to figure 10-7, and we interpolate on that sloped line, and we get 1.213. And again, if we apply our proportions, we end up with an adjusted CMF for lane width of 1.122. Now, if we look at shoulder width, it's 0-foot shoulder. So if we go to figure 10-8, we get a CMF of 1.375. Since there's no shoulder, the type doesn't matter, so that is a base condition. Essentially, all of the shoulder is paved since there's no shoulder available. So you can, so that's why you have a 1 in there, and you get an adjusted CMF for shoulder width of 1.215. So then the total CMF for lane and shoulder width, you multiply those two together, and you come up with 1.364, or approximately 36.4% more crashes because of the reduced lane and shoulder width. Okay, so there's also a CMF for horizontal curves. And at this point, I'm going to bring up a quick poll. How many people sat in on the horizontal curve workshop or webinar on the 14th? So I'm getting some responses back. We're up a little over 20. And again, this is this webinar today is the 11th in the series of webinars that we're doing to try to support the Highway Safety Manual and touch on several different areas that might be of interest. It looks like about a third or a quarter of the people on this webinar so far were not on the previous webinar. That is a recorded webinar that you can go out and view later if you want to. It gets into more detail on specifics of horizontal curves and some of the countermeasures that you might encounter there. We're just going to primarily talk right now about the basic CMF for horizontal curves. So for horizontal curves, there's several factors that might affect how many crashes you might expect on a horizontal curve. You might get involved with lane and shoulder widths through the curve and things along those lines. But for the CMF that we have available to us, the basic inputs are the length of the curve, the radius of the curve, and whether or not you have a spiral transition leading up to the curve. And so here you have the equation that brings in both the length of the curve and the radius and the spiral transition. We're going to go over an example for the horizontal curve. The length of this curve is 480 feet, which equates to about 0.091 miles. The radius of the curve is 350 feet. There's no spiral transition. The central angle is 78.6 degrees, which really isn't an input into the formula. So here we'll have a CMF equation. We input our length of our curve at 0.091. We have 80.2 divided by the radius, which is 350. In this case, we had no spiral transition, so that goes to 0. And then we divided by 1.55 times the length. And for that, we come up with 2.62 is the CMF. So that means that you multiply by 2.6 the number of crashes that you might expect if there was no curve at all. In addition, we also have a CMF for super elevation. The CMF for super elevation is based on a variance between your standard or your design super elevation and what you have in place. For example, if you had a super elevation variance that's less than 0.01, that's a base condition, so you use 1.00 for that. If you varied between 1% and 2%, then you have a CMF that has a formula as I've shown there, 1 plus 6 times the super elevation variance minus 0.01. If it's greater than a 2% variance, then the equation changes somewhat. And you can see the equation there. For an example, if you had a design super elevation of 4%, but your actual is 2%, your super elevation variance would be 2%. And so you use the equation for the 2% or greater. And if you calculate that out, 1.06 times 3 times the difference ends up being 1.06. Another factor or another countermeasure that might be applied is on 2-lane rural roads. This is only on 2-lane rural roads now, is a CMF for centerline rumble strips. There isn't a CMF in Chapter 10 for shoulder rumble strips at this time. When the Highway Safety Manual was coming up for publication, there was only confidence in the centerline rumble strip at that point. In future editions, we think that we will see the shoulder rumble strips added in as well. For centerline rumble strips, you can see that there's a CMF for all types, all severity of crashes of 0.86. When we look at the CMF for head-on and opposing direction side swipes of all severities, it's 0.79, and head-on and opposing direction side swipe injury crashes of 0.75. Again, If you like to use the term crash reduction factor for a 0.75 CMF, that would be about a 25% crash reduction factor. This again applies to 2-lane rural roads. You can see the ADT range between 5,000 and 22,000 on those roads. So those were the crash reduction factors, or the crash modification factors that are in chapters 10 and 11 relative to keeping a vehicle on the roadway, the effect of vehicles leaving the roadway. Now what I'm going to go into is evaluating the potential for a crash frequency if a vehicle does leave the roadway. And in chapters 10, 11, and 12, there are several crash modification factors that are address this the frequency of crashes when a vehicle leaves the roadway. For the rural, we have the roadside design or roadside hazard ratings that I'm going to be going over. When you get onto multi-lane undivided, there's also a CMF for side slopes. For the rural multi-lane divided, we have a CMF for median width. And when we get into the urban-suburban, there's a roadside fixed object density. The roadside hazard rating is based on some research that was done by Charlie Zagier that evaluates what type of environment you have on your roadside. The base condition is a 3. The ratings range from a 1 to 7, with a 1 being a very forgiving roadside environment and a 7 being a very unforgiving roadside environment. This table that's in Chapter 13 gives some general guidelines of what different hazard ratings might equate to. And you can see for a hazard rating of 1, you have a greater than 30-foot clear zone, a flatter than 1 to 4 side slopes that are generally recoverable. When you get down to rating of 7, you generally have steeper slopes and less recovery area available. I'm going to be going over each of the hazard ratings now. Again, for a hazard rating of 1, you generally would expect to have wider clear zones. You can see greater than or equal to 30. Side slopes that are flatter than 1 to 4, and generally recoverable side slopes. When you start getting into a hazard rating of 2, the clear zone might be between 20 and 25 feet from the pavement edge line. The side slopes are about a 1 to 4. The side slope, generally still recoverable. As we go into a hazard rating of 3, the clear zone gets reduced down to about 10 foot from the pavement edge. You can see on the left-hand side there's poles that might be about 10 feet off the pavement edge. You get steeper side slopes, so you start getting down to a 1 to 3 side slope condition. The roadside might be a little bit rougher in texture, more changes that might be expected as a vehicle traverses over the side slope, and you would generally consider it to be marginally recoverable. And again, this is your base condition on a 2-lane rural road. As we get into a hazard rating of 4, the clear zone is reduced down to about 5 to 10 feet. The side slopes are about 1 to 3, so 1 to 4. Now you might see guardrail popping up, and the guardrail might be between 5 and 6.5 feet from the edge of the pavement. You may have exposed trees, poles, or other objects, and you might consider this more of a marginally forgiving roadside, but there is still a chance of a reportable roadside crash. As we start getting into a roadside hazard rating of 5, we got clear zones that are between 5 and 10 feet, side slopes of about 1 to 3, virtually non-recoverable. You might have guardrail that's less than 5 feet from the edge of the travel lane. You also might have exposed trees, poles, or other objects within about 10 feet, or about 10 feet. When you look at a hazard rating of 6 now, the clear zone is generally less than 5 feet, as you can see on the picture to the right. The side slope might be about 1 to 2, which is generally not recoverable. Generally, you don't have guardrail, and you might have exposed rigid obstacles within 6.5 feet of the edge of the pavement. And 7 is the least favorable or least forgiving roadside environment, where you might have a clear zone that's less than 5 foot, steeper than 1 to 2 side slopes that are non-recoverable. You might have a cliff or a vertical rock cut, as you can see in this picture here. If a vehicle were to veer off the roadway here, it would be a very high likelihood of a severe injury or fatal crash. So those are the different hazard ratings. Now this is the equation for how to use those hazard ratings to develop a CMF. So the CMF for the hazard rating, you can see it, the roadside hazard rating is used in the exponent there. And we'll just show a roadside hazard rating of 5. So if you plug 5 in for your hazard rating, you come up with a 1.1429 CMF. So about 14.3% more crashes because you have a roadside hazard rating of 5 versus a 3 that's the base condition. And while one of the things with the roadside hazard rating is it is somewhat subjective in determining what hazard rating you're going to assign to a particular roadside. This chart gives some general areas that you might look at. You can also notice that the hazard ratings, there's CMFs for 0.5, 1.5, or 2.5. So some cases you might not have a condition that exactly meets it, and that is something that you have to decide what is the best hazard rating that you can use. And maybe in some cases it will fall in between the even numbers, and that's okay. You can see the CMFs are already calculated over on this table for the different CMFs. So when we look at undivided multi-lane rural highways, there's also a CMF for side slopes. The CMF in Chapter 11, this table 11-17, shows that for the undivided rural multi-lane, a 1 to 7 or flatter side slope is the base condition. So that's a 1. But if you go down to a 1 to 2 or steeper, you have a 1.18 for your CMF for your side slopes. For divided rural multi-lane highways, there's also a CMF for median width. And this is medians without a barrier. So if you have a median, you can see that the wider medians, you have a condition of a 30-foot wide median being your base condition, so you have a 1 there. When you get into lesser median widths, a 10-foot wide median, it's 1.04. So you expect about 4% more total crashes. When you get into a 100-foot wide median, it's down to a 0.94. So this accounts for total crashes on the segments. And when you think about how median crossover crashes are reflected, they're generally not a great number of them, but when they do happen, they're severe. So that's why you don't see a great swing when you're looking at total crashes. Now when we go into the urban environment, in Chapter 12, there's a CMF for roadside fixed object density. And you can see the equation here. The equation is based on several factors. One is the fixed object offset factor that we'll look at in just a second. It's on the table in Chapter 12. There's the density of fixed objects. That's fixed objects per mile. Then we also have a fixed objects collision as a proportion of total crashes. And we'll look at that in a second. Now this addresses point objects that are 4 inches or more in diameter that do not have breakaway designs. Those are considered your fixed objects. Also, point objects that are within 70 feet of each other longitudinally are considered as a single object. When you're looking at objects along your roadside and you're looking at a particular length of highway, you need to make sure that you're not counting too many when you do the calculation. Just an example for a 4-lane urban undivided street, which would be a 4U category, with power poles at 2 foot offset. We have an offset factor off of table 12-20. For a 2 foot offset, we have an offset factor of 0.232. For our proportion of fixed object collisions for a 4U, it's about 0.037. So those are the values come out of a table within Chapter 12. And so we'll just go through an example. This is for a 1 mile, 4-lane, urban, undivided, commercial curved street, 4U category. Has power poles on one side at 150 foot spacing, 2 feet from the edge of traveled way. So we use our proportion factor of 0.232. We divide 5280 by 150 feet because that's the spacing of the poles. We have 1 because they're only on one side of the roadway. And then we have our 0.037 for our proportion of crashes. And when you calculate that through, it comes up to 1.265. So about 26.5% more crashes because you have fixed objects at 2 foot offset. Now, if we look at having power poles on both sides of the highway now, or the roadway, we need to look at that, and we need to now put in that it's on both sides. So you calculate that through, and I'm sorry, I went too fast, and you come up with 1.567 crashes, or a CMF of 1.567. So that's for having it on both sides versus having it on one side. And the further off you have, your proportion factor, your offset factor changes, and that will adjust that. Okay, so those are the primary CMFs that are in chapters 10, 11, and 12. And those were developed and go along with the SPFs in those chapters. Now there's also other CMFs that are located in chapter 13. I'm not going to be going over each of these individually, just important for you to know that they do exist. This is table 13-7 that shows a summary of treatments related to roadside elements. There's CMFs for flattening side slopes, increasing distance to roadside features, down to installing curbs and clear zone, increasing the clear recovery distance that you can see there. So that's something else that you might want to go and take a look at to know what other CMFs are out there. The one caution is that when you use a lot of CMFs, your reliability of your equation might go down. The more CMFs you have in there, and the further you are away from your base condition, the less reliable your equation might be. However, I did want to highlight a couple CMFs that are in Chapter 13 that do affect, have an effect on the potential for vehicles leaving the roadway. I know that this was brought up in previous webinars, wanting to know about the safety effects of continuous shoulder rumble strips. So there is a table 13-44 that shows the effects of installing continuous shoulder rumble strips on multi-lane highways. You can see the range of volumes goes from 2,000 up to 50,000. In this case, it's a multi-lane, undivided highway. And your CMFs for all severities of 0.84. When you look at the single vehicle run off the road injury crashes, down at the bottom, 0.78. So again, if you convert that over to crash reduction factor, it's about a 22% reduction of single vehicle run off road injury crashes. There's also a separate CMF for freeways. This is that you can see here. So this is freeway sections. You got urban and rural, and you can see the CMFs over on the right-hand side. There's also a CMF for installing raised pavement markers. Again, this is the intent is to try to keep vehicles on the roadway, allow them to see the alignment of the roadway at nighttime. And you can see that in this case, the crash severity types are nighttime crashes, and it has a CMF of 0.76 for your ADT between 15 and 20,000 vehicles per day. You might expect a CMF of 0.76 for for nighttime crashes. There's also a lot of other CMFs that weren't put into the Highway Safety Manual. Research is going on all the time, looking at different researchers evaluating different things. The CMFs that went into the Highway Safety Manual were considered the best of the best. They met a certain statistical rigor that was considered acceptable by the researchers preparing the Highway Safety Manual. But there are other CMFs that are out there that might be of use in some cases, and there is a CMF clearinghouse that is online. You can see the web link there. This is a screenshot of what it looks like when you go out there. It's a repository of CMFs. It's a place where newly developed CMFs can be shared. It also has some educational information. So highlights of the clearinghouse are that it's dynamic. It's intended to be updated regularly. It's searchable. You can go in and search for different CMFs that might be of interest to you. It shows CMFs as well as the crash reduction factors, which are interrelated. Also, it provides a star quality rating. And what that means is that for a higher quality CMFs, ones that have evaluated multiple locations and have many years of before and after data to back them up, they're statistically significant, there's been a regression to the mean evaluation done, those are considered a high quality, and they may have a 5-star. A 1-star CMF might be one that's been one location where you had 1 or 2 years of before and after data. So it might be a somewhat very specialized or unique situation, and you just want to be aware of what the quality of your CMF is. So this will present all CMFs that are input into the database, and then the quality rating lets you, the user, understand how it was developed and how you might use it. It also indicates whether it's a CMF that's in the Highway Safety Manual. It is based on user submissions of, as research is done, the researchers might submit their CMFs into the database for consideration. The content, when you look at the clearinghouse, the HSM is considered to be the best available CMFs that were available at the time that the HSM was published. There might be some CMFs that are very high quality come out right after the Highway Safety Manual is published. Those will be out there and available to you at that point. But the CMF clearinghouse incorporates all CMFs, so there might be some that are less quality than others. Now in the future, the Highway Safety Manual incorporated the best research that was available at the time. But we also know that CMFs are being developed and added to the CMF clearinghouse. We hope that that's routinely happening. There's also a NCHRP project, number 1754, that's entitled Consideration of Roadside Design and Roadside Features in the Highway Safety Manual. It's going to look at those features relative to the roadside design and try to make sure that we got, if there's additional research that's needed, we'll try to do more of that research. And then that should be available for the second edition of the Highway Safety Manual when it comes out in the future. So the Highway Safety Manual should be a living document that's updated just as all of our other documents are, like the Highway Capacity Manual and our Green Book and Roadside Design Guide. And so as more research becomes available, that will be incorporated into the Highway Safety Manual. So at this point, I'm going to hand it back over to Frank to kind of give us a wrap-up.
Yeah, I put this slide in primarily to show the link to the Highway Safety Manual at the AASHTO website. And basically, the reason I did that is because it has a lot of links there for training as well as other resources. Obviously, you can get the link there to how to get the book and all that sort of thing as well. But the training aspect, I will quickly kind of cover. There's a lot of training classes that are available that are more for practitioner type of application. And one is the Interactive Highway Safety Design Module course, which you'll notice that that's an NHI course, National Highway Institute. But that is referenced on the AASHTO website for the Highway Safety Manual. So you can go to that and give you some information about this as well, but it'll link you back to the NHI course. This is currently available now. And also the safety analysts. There's been a number of states that have been involved with this, the development of the safety analyst. And there's a training course out there available, NHI course 380075. And, you know, there's a number of states that are starting to actually use that and start getting into the early stages of it as well. And, of course, we also talk about the 2-hour webinars we've been doing already. Some of these are actually have links currently on the AASHTO website to the recorded sessions. And that's kind of important because everybody that participated gets an email basically telling them how to get the recorded versions, but people who didn't sign up initially don't know about it or don't get that email. So consequently, it's good for them to be able to get in there. There's so many people that are tuning into this webinar that are not necessarily at the state. There's a lot of local and engineers as well as consultants, so they may not have got that information. So that's on that website. Also, some other courses. These courses have been modified to reflect the upgrades in the Highway Safety Manual as it's been, but these courses have been out there for a while. So if you had this safety effects of geometric design several years ago, you might want to get it back because it's got some new and updated information. But that's course 380070A for 2-lane rural roads. If you want to go to multi-lane roads, it's 380070B. And oftentimes those are taught simultaneously, in sequence together, so that they can get the benefits from both those pieces of information. Of course, there's also a overview. Now, this is something that has recently been. I guess we've had 3 pilot courses around the country at different locations, and 1 at TRB. But this is really something to give people a broad overview. Still a little bit more in depth, obviously, than what we're doing on the webinars, but certainly some of your management may need some of this information to understand what this really means. And Dick, of course, talked about the crash modification clearinghouse, and which really addresses things in Part D. That's also an online training course with that, which is being sponsored out of Federal Highway Headquarters. It basically not only talks about some of the details that Dick mentioned in his presentation, but also some other aspects of crash modification factors, general information. So it's a really good course. That's it. I guess I'll turn it back over to Gene now, or take questions.
Yeah, if you're done, we will open it up for questions. I know we have a couple of hands raised from NDOR and Benton County, I believe. So, Carissa, our operator, if you could open it up for questions at this time, we'd be grateful.
Sure, and if you'd like to ask a question, please press star 1 on your touch-tone phone. Please remember to unmute your phone and record your name clearly. To withdraw your question, please press star 2. Again, if you'd like to ask a question, please press star 1. One moment, please.
Okay. And while we're waiting for that to take place, there are a couple of questions in the chat pod. Dell Widener from Caltrans asked about cut slopes that are not vertical, as shown in the photo, but maybe a 2-to-1. And I tried to respond to that by saying that a 2-to-1 is a non-recoverable slope, and depending on what you have in the vicinity of the roadway, whether you have a lot of fixed objects, that would probably be in the vicinity of a hazard rating of around 6. If it's just a short slope, it could be less than 6, or if it's a long slope, it could be higher than 6, so it just depends on what you have. Dick, Amanda Watson's asking, what's the definition of a raised paint marking? I think she might be a raised pavement marking.
Yeah, but raised pavement marking would be a, I don't know if I have a set definition here, but it's a object that sticks up in the lane lines, or where it gives, especially at night, it gives a little bit more retroreflective bounce back to the driver. So it sticks up, so it's raised. Frank, do you have a better definition? I'm
No,
sorry.
but I do know that the question has come up because some states use a textured pavement marking that is paint or epoxy or some type, and that's not what was in mind here. This is really talking about the RRPMs that you see. They're not they're not like a stripe. Obviously, they're fixed at usually 40-foot spacings unless you're in a curve, or 80-foot in a lot of states. So that you really see that's the type of evaluation they're talking about, RRPMs, not textured striping, which I think may be where that question was going, because I've had that question before. I don't think we have anything for that yet. Whereas the RRPM types are pretty commonly used, and I know the report was the source for this. That's what they used.
I guess David Gee is asking if those are the bot dots. I'm not sure if I know what a bot dot is.
That's a common term that was used. Yes, these are, I think it's the source of this was the study from NCHRP 518, I believe, was the source of this.
And Amanda, yes, you're correct. Those are the reflective items that are in the center line. Usually they're in the middle of the gaps between your pavement markings, pavement stripes.
And they're beneficial in wet weather, and they're raised basically above a normal pavement mark.
Right. And we have a question from Gil from New York State DOT, I believe, asking, can you define what a crash is? Isn't leaving the road a crash?
I think I would look at the threshold reporting. A lot of times you have people leave the roadway and recover back, and while technically the vehicle has left the roadway and there is some risk when that vehicle leaves the roadway, if it's not reported, it's kind of like the tree that falls in the woods you don't hear. I mean, basically it's we know they're out there. You can see the tire marks and this sort of thing, but we don't always know those. So that doesn't get reported as a crash. So that can be discussed, I guess.
Yeah, and states have different thresholds for...
Yes, certainly. That varies greatly.
Exactly. Operator, do we have any questions verbally?
At this time, there are no questions on the phone.
And Gene, I guess it was pointed out by Missouri DOT that we might have had an error in one table about the IHSDM is for Part C and the safety analysis for Part B.
Right.
So we apologize if we made that error
Right.
on the slide.
Okay. I did not notice that, but somebody did.
I think that's in a couple other sessions too.
Are there any more questions? Verbally or in the chat pod?
There are none on the phone.
Okay, we have a question that came in the chat pod from Gil. He's asking, New York, how does a roadside object increase crash potential? And I guess the answer to that is that the object doesn't increase crash potential, but the traffic volume does. So the more traffic volume you have on a roadway and you have fixed objects in the vicinity of the roadway, then there's an increased likelihood that an errant vehicle could strike that object. So if you look at the safety performance functions and things, the crash methodology in the HSM, you will see that traffic volume is one of the major variables in crash prediction. Bill Widener from Caltrans asks, what about less paved shoulder, say 4 feet, but increased clear recovery to say 40 feet? Dick, you want to try to handle that one?
Well, both of those have an effect. We showed the effect of shoulder width. So if you, and I'll just talk about a 2-lane rural road for a second. So if you have a 4-foot shoulder width, you might expect more crashes because the base condition is a 6-foot shoulder width. Now, if you also provide a 40-foot recovery area, that would give you a roadside hazard rating that would be fairly high, low, so that would probably be a 1, and so that would have a different effect. So I think both of them can be evaluated. And it might be a trade-off in some cases to provide more width of one or another in some cases, but I think both of them are valid things to evaluate.
They both could be analyzed and thrown into the crash prediction modeling and come up with a expected crash frequency for something like a 4-foot shoulder, but a much higher, or I should say lower hazard rating, and then you can make a comparison between the two and make a decision. And that's what we're basically finding out is that the HSM is more a risk management tool. It's a tool that helps us to analyze or predict crash frequency to make better design decisions based on the types of projects that we're putting out there on the roads. We got a question from John Campbell. Do roadside hazard ratings of the HSM match the roadside hazard ratings in the U.S. limits program, which is also a 1 to 7 rating? I don't know the answer to that. I have not seen the roadside hazard ratings in the U.S. limits program. They sound similar. Dick, Frank, have you seen the roadside hazard ratings in U.S. limits program?
No, I haven't really delved into that, but I got to tell you, it probably does. Just guessing, because, and I'm going to have to say that as a guess because I haven't looked at it, but everywhere you turn, there's a lot of this information was developed, as Dick mentioned earlier, by Charlie Zagier. It's been used in several references, so you see this come up quite a bit as a reference to severity of roadside. So I would, and a lot of the same people overlap with the development of these things, so I can't imagine it's not.
And you're probably, I would agree with what you're saying. A lot of this research has been shared among different
Researchers and so forth, yes.
Researchers to come up with, different safety programs or modeling, I should say, I guess is what I'm trying to say.
Right. Gene, I would like to go back and add a comment to the issue. I think the question, and I'm wondering where that question was coming from, but where the guy said, well, how can you add an object and it increase crashes? The issue is that I guess what he's really referring to, how do you add an object and it causes vehicles to run off the road, really is what he's saying. What it doesn't, but as you pointed out, it's an ADT exposure. What people don't realize is how many times people or vehicles run off the roadway and recover and we don't know about it. The real truth to that, or key to observing that, is that like a lot of our roadways where we've gone back in and added barriers, particularly continuous long runs of barriers, and cable being one of them, is that you see how many hits you get on something like that previously you had unreported, are very few, and of course those few are severe type of hits. So what we've done is, of course, lower severity, but you start finding out how many people do leave the roadway and recover successfully when you provide a proper clear zone. And that's what happens with putting a fixed object out there, is you don't have the people, you don't give them the room to recover. And it's all a probability issue as far as how many people will recover within a certain distance. So, or on certain slopes as well. But that's, that may be kind of related back to what the other question was about what is a crash. Of course, and I thought about another, maybe they're asking us, is there a difference between an accident on an accident report? The terminology, of course, is the real difference. The vehicle being banged up is still the same, but a lot of states still have what they call an accident report, and some states have already changed to crash report. But in essence, an accident referring to an act of God, and that's why many people objected to using that term, because crashes actually can be predicted and controlled if you manage the details.
We have a question from Dan Thompson, and I'm just trying to go down in this sequence of the questions are being presented here. Dan's asking, why doesn't the deflection angle have an impact on crashes at horizontal curves? It seems intuitive that a curve with a deflection of 9 degrees would experience more crashes than a curve with a deflection of 5 degrees.
I guess my answer on that would be is, when the Highway Safety Manual was put together, they pulled together the best research that was available at the time. The researchers that looked into horizontal curves found that the length and the radius were the critical factors involved with the horizontal curve crashes. Now, if somebody else was to do a research project and they found that central angle or the deflection angle was a bigger thing, maybe they'd come up with a slightly different relationship. But we don't have a study that's really borne that out at this point. We're using the research that's available to us.
And having radius is related to the degree of curve,
right,
anyway. So there is some relationship there.
Again, too, there's a control in this particular study because you're looking at, kind of you ground everything together with an outcome, and in the real world, of looking at a specific location. You're looking at the variable of the speed, and the speed is going to be a real big factor in the crashes on the approach speed to that curve. That's not in this prediction formula like that, but that's it. But in reality, if you're looking at a specific curve and you're trying to differentiate between one to the other, these factors are basically gone in and looked at the outcome. These are the variables that would control those outcomes in a large data set, and you're looking at averages over a long term as well. So just keep that in mind.
We have a question from Mr. Savlin, California DOT. To better understand, do you mean to state that only crashes or collisions are those that are reported? No, I think what we're saying is that each state has a different reporting threshold for crashes. Certainly there are crashes that are reported that have low monetary damage, and there's other crashes that are reported that have high monetary crashes, and these are just different from state to state. And we're just trying to point out that there are differences in crash reporting from state to state. Go from New York State DOT, how does roadside advertising affect crashes? We don't know. There's nothing in the Highway Safety Manual that addresses roadside advertising. That may be something that comes up in a future edition for a CMF, but right now I would say there's probably not enough research that's been done that they can quantify that particular effect.
Gene, and even to point out, like that particular issue where there is other research already, there is some things out there, but it hasn't been quantified to the degree that you need for inclusion into this book, which is, very robust studies and large data sets. That's what, that differentiates this from other types of, I'll say previous safety efforts, is that this one is based on so thoroughly on the research and really, I would say, put to a high test to see whether the data is good or not.
Right, and we're definitely not trying to say that the HSM covers everything that's taken place on our roadways. Both the researchers and AASHTO are quite fully aware that there are some gaps in this first edition of the Highway Safety Manual, and they're holding discussions right now to try to decide what should be in the next version of the Highway Safety Manual. What research, and they're even targeting specific, or trying to identify a specific topic for further research so that they can maybe quantify some of those research so that they come up with a measure for a particular safety effect of a particular safety countermeasure.
And Gene, that really points out the benefit of that clearinghouse, because, stuff that's going to get included in this book is really going to be things that are most applicable to everything, the gaps that are needed by, the biggest number of users. And so there will be studies that follow this, probably that'll make the clearinghouse. It might not make the Highway Safety Manual for some time. Some of the bigger issues are included.
Right, and the Highway Safety Manual is viewed as a living document. It's something that we can use, as an analogy to the Highway Capacity Manual or the MUTCD, or maybe not the MUTCD because it's a requirement, but to the Highway Capacity Manual, such that, as research becomes available, then updates to the Highway Safety Manual will take place to match whatever the research is available.
Yeah, Gene, somebody pointed out the other day that when the Highway Capacity Manual first came out, it was 50 pages, and it is continuing to grow and increase with knowledge. So I think this is the same model that we're looking at here.
Right. We got a question from Ken Brown. Are there studies to account for variances in posted speed, operating speed? I'm sure there are, but I cannot reference any per se. Can you, Dick or Fred?
I can't think, and there's none that I'm aware of that are in the Highway Safety Manual at this point, but I'm not sure. There might be some studies that have been done that look at differentials, but I don't think they're in the Highway Safety Manual.
Right. There have been studies looking at differential speeds, but like I said, that's not included in this yet.
We got a question to the presenters from Jason Osman. Your findings in the HSM do not include freeways and high AADT facilities. There are minimal, I should say, crash modification factors for high-speed facilities. That's another area that's weak in research. I expect possibly there'll be a focus of research or quantifying research in more high-speed facilities, multi-lane facilities, and freeways in the future. But for now, like I said, there are gaps in the Highway Safety Manual. The authors know it, the researchers know it, and we're just trying to address those as more research becomes available.
The answer to that is just time and money, right, Gene?
Yeah, well, John McFadden says this is Highway Safety Manual's a researcher's dream. They got tons of research that they can proceed on now. Gil from New York State DOT is asking, does a barrier count as a roadside hazard in the HSM? Does it have a lower CMF than other roadside obstacles? No, a traffic barrier or roadside barrier does not counted as a roadside barrier, though, even though in the roadside hazard rating, it does mention if you had guardrail in close proximity to the travel lane, that it kind of gives you an idea of how to come up with a roadside hazard rating based on the conditions that you have out there on your roadway. There are CMFs in the Part D of the Highway Safety Manual that are available that we're using a less rigid barrier, and we did not present them here because we just don't have time to present all the CMFs. But if you go to Part D of the Highway Safety Manual, there is a table in there that talks about provides crash modification factors for going from a rigid barrier to a flexible barrier, such as WB guardrail, and then going from guardrail to a more flexible barrier, such as a cable barrier or wire barrier.
But I think the main part of that, Gene, is that when you've got a guardrail that's within 10 feet of the roadway, that's generally going to be a hazard rating of about 4 to 5. And if you were putting it in front of a slope, otherwise the slope might have had a hazard rating of 6 or 7. So that's where you might see where a barrier is less severe than the object that you're putting it in for.
Correct. We have a comment from Amanda Watson. Roadside advertising is a visual distraction in the UK, led authorities to restrict their placement at complex intersections on and off ramps. Okay, sounds like a good thing. I'm not up to speed on the latest research on roadside advertising. I know it's a hot topic in our headquarters office, and they're looking at the different alternatives that are available, and have to wait and see what comes out of that. Pat Landry from Louisiana DOT is asking how the differentials in operating speeds used to modify with the CMS predicted using. Dick, you want to try that one?
Well, I think it's just like we talked about before. There's not any CMFs in the Highway Safety Manual that are related to the differentials between operating speeds and posted speeds. We just don't have that in there. If a great study is done that really relates it well, then maybe that'll be in the next edition. But right now we don't have that. What we do have is the studies that have been done that are based on length and radius, and that's just what we have at this point.
Thank you, Dick. Gil from New York State again is asking, are there CMS for unprotected traverse, culvert density, and or head walls?
I guess we looked at the different conditions. So you might have if you were looking at a rural situation and using your roadside hazard ratings, that would be essentially a fixed object, and it depends on how frequent they are and how far off the end is. If you're in a more of an urban, suburban environment, then you have the fixed object density CMF that you might incorporate in there. But there isn't a CMF specifically for culvert end walls. Now, that is something that as the NCHRP project is looking at how roadside elements are incorporated into the Highway Safety Manual, maybe something along those lines would be, further developed. But right now it isn't there.
Sarah is asking, can we listen to you through a headphone instead of a telephone? Depends if your headphone plugs into your phone base. I think the question is maybe from the computer. All of the audio portions from these through the web conferencing is provided through a telephone line only. So you cannot use it. It does not direct sound into your computer directly. Lamb's asking, are there different CMFs between one row, 1 foot wide rumble strip on the center line versus a 4 foot wide 2 row rumble strip soft median barrier? Not sure if I understand that question, Dick. Do you?
I think you're just talking about different designs and rumble strips and where they're located, because there's a variety of ways these are done out there in the field. I think what you could do is you could go in and look back at the data sets that were used for the information. It goes back to what was the base condition when we were talking about the SPS. It's kind of similar kind of thinking, is if you look at what was studied in those locations or in the data sets, you'll find which is most commonly used and see if it's similar to yours. Other than that, I don't know that you could actually adjust it, because I don't think there's anybody quantified that. But certainly the closer your design is to the data set that was used, the more likely you're going to have replicate those kind of numbers.
Yeah, and now you said that, it makes sense. Thanks, Frank. I see a hand raised. Mara, operator, do we have any questions, verbal questions?
At this time, there are no questions on the phone.
Okay. I think we've gone through all the questions in the chat pod. I'm going to go to the wrap-up room now, and if you have a question, go ahead and enter it, and we will answer it. But in the meantime, I'd like to thank everybody for participating in this 11th of 12 webinars. Our 12th webinar will be on HSM applications to the HSIP program, which is the Highway Safety Improvement Program, on August 4th, which is next week. Links to the recorded sessions of previous webinars are located in the file pod on the upper right. And directly beneath or in the center of your screen is the HSM webinar series presentations. If you've not had the opportunity to download presentations at the beginning of the webinar, you can do so at this time, and we will leave this screen open so that it's available to you for the remainder of the day to download presentations. There are no more questions. I don't see any new questions in the chat pod. We don't have any new questions on the operator. Then that will conclude our presentation, but I will ask Dick and Frank if they have any last comments they'd like to make.
I'm good.
I'm good.
Okay. Thank you, everybody, for participating, and at this time we will conclude the webinar.
This concludes today's conference call. Please